Heading on to the next demonstration, we're going to hit the demonstration 3 button and connect to the PSNC testbed that actually hosts this demonstration scenario. Now, according to the scenario of this test, we are going to increase the energy prices as if we were an energy provider or a distribution service operator, and the data center should provide balancing services by lowering the absolute energy consumption up to a certain percentage, so that the data center operation costs remain more or less the same or even less than before the energy price change. Now, heading on to the demonstration site infrastructure, we can see over here in this tab the running services of the Dolfin system. As you can see, we have stopped the ADR service so that we can control the energy prices ourselves for the demonstration scenario purposes. Also, we can see here in the ECOP-DB interface that a total of 67 VMs are hosted in this trial, and these VMs are all hosted under 8 servers, as you can see over this screen. So moving on to a random one, we can see that this, for example, R5 server is a 32 core one with 2.4 gigabytes of maximum frequency. The RAM is set to 64 gigabytes. We have approximately 1 terabyte of hard disk, and here we can see that the servers that have been provided are more or less energy efficient. Now, this particular server here hosts a total of 9 VMs. We have a number of actions here as well, and of course, as usual, the latest measurements for the server. Now, all the servers are located in a single rack, for which we can also get the energy values as are monitored by the ECOP monitoring platform. Now, moving on to the actual demonstration, we can see that the smart grid controller is currently not aware of any energy prices. Hence, what we are going to do first is to set the absolute price for the energy. Now, this one is the latest known to the Dolfin InfoDB, as was provided a few days ago by the smart grid controller, but this has not changed yet, so we should inform the smart grid controller about a new price, even if this price is the same. So, after having set the base energy price, you can see in the diary over here that the generated calendar by the SGC has been updated with a new price. Now, heading on and increasing twice the energy value, over here, what we would expect is that the policymaker realizes the increased energy price change and sets an optimization request towards the optimizer to minimize the energy consumption. So if we check the policymaker logs, we have to wait for a few seconds. As you can see here in the screen, the policymaker actively polls the Dolfin InfoDB in order to get the current prices as were informed through the SGC interface. So what happened right now is that the significant price change has been detected. We have 100% of differentiated energy price. The policymaker authenticated against the optimizer and successfully changed the optimization policy of the DC to render the overall energy consumption of the data center to be half as it was before. Then what we saw is that a new optimization request was issued to the optimizer. So if I go in the optimizer and hit on the request tab, we can see that there is this new plan over here, number 18, which generated a plan with ID 84, which says that the expected energy consumption if this optimization plan is applied is 54%, thus really close to the policy set by the policymaker. This plan includes a number of VM migrations, a certain number of VM relocations to another data center, and of course a number of server actions. Heading on to the policy that was used, its ID was 77, which is the one sent by the policymaker. So the optimization target is energy efficiency, and the constraint was that the maximum relative value for energy should be 50%. Also, cross-DC load relocation is allowed, but stopping VM was not. So moving on to the rest of the Dolfin infrastructures. We can see, for example, from the InfoDB logs, they have to be updated. Let's check the cross-DC VMM. So as you can see here, VM relocation has already started. Oh, here is one more. So if I check the VMs that are known right now to the region 2 Dolfin installation, namely DC1, we will see that the VMs are no longer 67, but a bit less. Also, the energy consumption should be lowered only in the case that the whole optimization plan gets actuated, namely the servers are shut down, etc. However, we should be able to see even a slight energy change right now.